as Devin mentioned, I want to talk about React and GraphQL at Stripe, and I'm really glad about the talk that you all just heard because one of my goals is to present specifically about the things that I feel like are unique about the implementation of GraphQL that we've come up with at Stripe, and not reiterate a lot of the benefits and things that you might have already heard in a general overview. So I think it's actually going to fit together really well. So quickly, just an overview of what I'm talking about. First, I want to talk about how GraphQL fits into the modern development stack and why I think it's so important. It's going to like really change the game and is changing the game. A couple of new tools that we built at Stripe that I haven't seen yet too much out in the wild that I think people would get a lot of benefit out of knowing about. And then some of the unexpected benefits of adopting GraphQL at our company that I didn't really hear as much about as I thought I would hear. But as soon as we implemented, I was like, oh my God, this is like a really good reason to do it. So I'm excited about these. So a little bit of background about me. Why am I giving this particular talk? So in 2015, I was actually working at Apollo. So you heard about some of these tools provided by this company that works on a lot of GraphQL stuff. I was actually working there for about 4 or 5 years, building all these tools, Apollo Client, Apollo Server, all these things. Eventually, was at this company for a very long time, decided to join Stripe. And at Stripe, naturally I ended up on the team implementing GraphQL inside of Stripe. So got to get some continuity there and helped build out a GraphQL implementation to connect Stripe's backend specifically to the dashboard, which is kind of the main front-end application that Stripe has. It's the thing that you see when you log in. One important note before I go further is that it's important to realize for a lot of these talks that all these things that I'm going to tell you about weren't done by me or just me. They were done by a whole team of people that work at Stripe and do all kinds of great stuff. So that's like just an important thing to think about. So what's special about the Stripe dashboard from a product point of view? Well, there's probably a lot of products that feel like this, but one thing that really stands out to me is the Stripe dashboard is more of like a surface or a platform. All the teams at Stripe that work on the dashboard are actually mostly working on supporting all the other teams at Stripe that build the products to be able to build their product into it. So we have all kinds of products like Radar, Billing, Connect. You can check them out all on the website. And the parts of the dashboard that work with those products are actually built by those teams, not by a separate team that maintains that front end. And so there's a big job here figuring out how to have this super large code base with tons of features where actually just totally different teams from other parts of the company are contributing to it. How do we make it keep working and not fall over and not have like our one team be on the hook for everything being good? And just to kind of recap before I get into the rest of the stuff, we're working on a pretty standard kind of web stack here. We're using React, we're using Flow versus TypeScript, big debate, not getting into it. Jest, Webpack. We use Ruby on the back end, Stripe, one of those big kind of Ruby companies you might hear about. And the newest addition, of course, I'm going to talk a lot about today is GraphQL and Apollo. So quick overview of kind of like the nuts and bolts of GraphQL for people who might not be familiar with like what it looks like to actually write a GraphQL query. The first most important part about GraphQL is that you define a schema for your data. So with a lot of API technologies, static typing isn't built in. With GraphQL, it's literally impossible to have a GraphQL backend that doesn't have strong types for every single thing in it. So you go basically from a list of endpoints, if you're using a REST API that can fetch one or multiple objects, to a schema that has different types of data that might be also interrelated and interconnected. Like you can see here that an author might have some posts, a post might have an author, there's all these kinds of relationships. And the other half of that is the GraphQL query. So once you've built out the schema, the way you get the data from that is you type up a query, and that lets you get as few or as many fields as you want, and also traverse these relationships between those types. And queries are usually sent just one query per request. You send it in a post request to a GraphQL endpoint, which might just be a URL like /GraphQL or something like that. So now you pretty much know most of what you need to know about GraphQL for the rest of this talk. And one thing that I think it would be remiss not to mention, and kind of the biggest reason why we started looking into using GraphQL at Stripe, is that it really makes, I don't think it's a stretch to say this, it really makes developing for the front end and working with data fun, and way more fun than it used to be before that. We often get this feedback once we implemented GraphQL. People are like, I actually enjoy fetching data now, and before it was like kind of a slog. All you have to do is take that GraphQL query, put it into your code, use a query component from Apollo client, and it gets you all the stuff you need, including error states, loading states, polling, retries, whatever it is that you need. So let's take a step back for a second and think like, why is this GraphQL thing important? And the previous talk definitely referred to these things a couple of different ways, but I want to kind of like really focus on like what I think it is about GraphQL that makes it worth talking about at all these meetups. You know, isn't it just like a library or a technology or a spec or something? So if you were to take a really simple view of kind of modern product development, you might end up with a diagram like this. You know, there's front ends, there's back ends, in the middle of there's an API, there might be a gateway, stuff like that. But in reality, I think it's far, far, far more complicated than this, because that's ignoring kind of all the other things that are involved in development. There's not just the code that's actually running when you deploy your application to production. There's all the stuff that you use along the way to write tests, to type code into your editor, to generate static types, to build UI components. You might have multiple backends. You might have a CI system. There's all these things that interact during your development process that aren't strictly part of your application, but they're just as important to make it so that your development velocity can increase. So what I would say is that the most valuable systems for us to look at as developers are things that can tie into all these different aspects of your development and improve all of them kind of at once. So one example I think that kind of comes to mind that I think we can all hopefully agree with at a React meetup is that the idea of UI components was an idea that was kind of like this. Before, when we used to think of things as like a whole page, you know, with Ruby, you might have an ERB template that's like a couple thousand lines long. You got your page, you go to make your second page, another couple thousand lines, you're good to go. Component systems like React or even Angular have made it so you can start to reuse different components, you can start to arrange them in style guides, you know, use React Storybook, whatever. So I think that GraphQL is very similar. So when we look at the parts of the system that are actually GraphQL, it's really just the data management component and that API that it fetches data from. But a big point of my talk is that the benefits of using those two components of GraphQL stretch to like almost all of the other aspects of your development story. So when you think about adopting GraphQL or what the benefits you should be looking to get out of it, you shouldn't be thinking just what is the best way for me to fetch my data, but I think you should be thinking about like, how is this going to affect my development workflow? And so those are the parts that I think I found kind of the most interesting and surprising about adopting GraphQL at Stripe for the dashboard. So to kind of like zoom back into GraphQL for a second, I think the thing about GraphQL that makes this possible is precisely that it's not just a library, but that it's this like two-sided specification where one side defines the data that you have available in the schema, and the other side defines the queries that you use to specify which parts of that data you want and how they fit together. And you can use that to build all these wonderful tools. So here are just a couple of examples of benefits that GraphQL builds to these different systems. Like, for example, monitoring is one that really stands out to me here because let's say you have a REST API, you might have the most sophisticated monitoring possible, but you still won't be able to figure out of that REST API response that might have 10, 20, 50 fields, which of those fields is the front end actually using? Because when you fetch that endpoint, you get all the fields back. But with GraphQL, kind of maybe for the first time, it's possible to know this field is being used by these clients and this field is not being used, which lets you do stuff like actually remove fields from your API without bumping the version of your API, which is like pretty sweet, let me tell you. Okay, so gone over some of the kind of like high level benefits of why I think GraphQL is actually much more important than just like, how can we fetch our data? Like, is it performant or whatever? And I want to jump into some of the tools that I think really demonstrate this, and specifically some of the tools we've built at Stripe that I haven't yet seen outside. I was really excited to be able to, you know, even though I'd been working on GraphQL tooling for several years, to kind of jump in and find that there's still a lot of new stuff to be discovered. So mocking is one thing in particular that stood out to me. So just to like ask the question, like, why do we want to mock things? I would say it's because often when you're developing your component, you're writing unit tests, you're writing component examples, you don't want to deal with calling a real API. It's super messy. You want your tests to be faster than that. You maybe don't want to wait for the backend to be built to start prototyping. And it might be hard to click around your UI and generate certain edge cases, right? Like, you ever have those types of situations you don't really test very well because it's kind of hard to get there, and then they end up breaking. So that's a good reason to do some mocking and, you know, save that JSON blob and say, like, this is the failure state that I want to test over. So thankfully, from the start, GraphQL has made mocking really, really easy. Because you have the static types that describe what type every field is, you can say, this is a string, this is a number, give me a string, give me a number. Pretty simple. That's something that we've been able to do since 2016 at Apollo released this library GraphQL tools that let you take a schema string, call a function to add mocks to it, and then pass any query of any shape and get that shape back as mock data. So that's pretty cool. But unfortunately, just having a schema that returns mock data for different queries wasn't really enough to test specific edge cases. You might want to see what happens to a component if you have a really long list. You might want to see what happens in a particular error state or loading indicators. Or maybe you want to count how many times that component makes a request to the server. And so all those things weren't as easy as it could have been with that global mock system. And so one thing that a lot of people in the GraphQL community have done a lot is do per request mocking. So when you're trying to mock the request for a particular component, you list out every request that you expect it to make, then you list out the responses that the fake server should return, and then that's pretty good. So this is like a code snippet from the Apollo docs about how to do that. And I think when people do mocking for REST APIs, for not GraphQL, I think this is pretty similar to what I've seen as well. People create some fake data builders, stuff like that. So this was kind of like what I was expecting when I came to Stripe. But I think what we came up with was a system that allowed us to bring together the best of both worlds and achieve data mocking nirvana of sorts. And one way to refer to it is global schema mocking, but with local overrides. So you want to be able to have this huge world of fake data that you can pull from. So you can write any GraphQL query and say, I don't care what this returns, just return something that will make my component render. But sometimes you want to test, like, what happens if I set this one field to a particular thing? And so that's exactly what this does. And there's this component at the bottom that's kind of like the star of the show, this Apollo mocking provider that we'll be talking about. So at the top, you can see we have this custom resolvers object that says, in the case of the to-do items, I would like to have one to-do item that is completed, and I would like to have one to-do item that is not completed. And it turns out the query the component is doing that we're testing actually needs a whole lot of other fields. It needs the text field, the owner, the name, like all this other stuff. But for this test, we don't care about that. We just want those two items, and we just care about those fields. And so this lets us do that and get kind of the best of both worlds there. So, just to show some raw code examples that I very carefully copy and pasted from the Stripe code base. Very anonymous types like address, just to pass the bar here. But here's an example of a mock for an address type. So we use this library called Faker that lets you generate like realistic looking data. Here's a mock for a user. We have this little ID mocking function that says, this can be any string you want as long as it starts with USR, because Stripe has this convention of labeling IDs with the type that they represent. So this is kind of what our global mocks look like. And then it becomes really easy to do something like, I just want to check if this page renders at all. So this is also a real screenshot from the code base. We have this one page that's implemented with GraphQL. This is just saying, I want to render this component, make sure there's no errors when rendering it. We're good to go. Okay, so that's pretty simple. But now what if we do want to do some of that overriding? So in this example, we want to not just check that the component rendered, but we want to check that it rendered with actually the values that we got back from the API. So at the top, we specify some of those values, like the currency that we want in our balance summary. And then at the bottom, we can assert that those values showed up in the component. And so in the particular case of this test, we don't care about any other fields that that component needs to render itself. Like if somebody goes by and adds some more fields to that GraphQL query, like we don't care. We just care if like the field we showed up at the top, if that showed up when the component rendered. And this test lets us do that in a way that's not brittle when we start modifying that component in the future. And I think that's very exciting. A couple of other cool things about the mocking setup we've set up. We have specific components for mocking error and loading states. So one of these components means any query this component will do inside it will error for sure. And then the loading provider, any query that component does will just remain loading forever. And so if you just want to check that the loading indicator showed up or if the error was rendered in the right place, super, super easy to do. So this kind of like, one by one, we're covering all these edge cases that at first we implemented a certain kind of mocking. People started migrating their components to GraphQL. They were like, hold on, I need to write all this code. And we were like, okay, what if this was like one line? And that was really exciting for me to be able to work hand in hand with developers that are actually trying to use this stuff. And then one thing that I think is like kind of like a really cool result of having this like kind of like pretty powerful but simple system is this is a use case that we came across relatively recently, which was somebody wanted to implement a component that does a mutation and then actually like check the whole flow of like that mutation being called, the result being come back, the result coming back, then rendering in the component. And they were like, I don't want to write out all the requests and responses for that either, because like that's so like 2018. And so you can even do that, because what you can do is you can create a just mod function here at the top, and you can say, I'm going to create this fake function. You can pass that in to replace the mutation. Then you can render the component, actually simulate the click on the button that sends that fake mutation. Then you can both check that the mutation was called using that just function, and you can render that component and check that the result actually showed up there. So one thing that makes me feel really good about the system is I'm finding it hard to imagine like what a better version of mocks would look like. Like essentially, this feels like the minimum amount of code to even like write down what you're trying to achieve, which is like, I want this mutation, it should be called this many times. Here's the component, click on it, get the result. And so like, pretty awesome. So this is one of the things I'll do is I'll post kind of the slides after the talk. And we have a blog post that has some of the code that you would need to implement your own Apollo test provider. So you can totally check that out afterwards. So really stoked about that. One more thing. This is kind of a really cool example of GraphQL combining with a different developer tool that we have at Stripe that I'm really excited about. This is actually gonna be a live demo, super exciting. Woo. So we have this tool called SailPen. I guess I can just show it to you instead of trying to, show it to you on a slide. And SailPen is, Sail is the name of our internal component system. And SailPen is like a code pen or code sandbox, but internal to Stripe that uses our internal component system. So you can see that over here, we have a little component rendered using our like component system. So, very little code. This is kind of some of the code there. And it turns out that the SailPen tool that we use to prototype UI, and I've actually seen like entire pages of the dashboard built out in this tool by like designers, which is like super sweet. This is also set up automatically with GraphQL mocking. So you can see here, we just have the Apollo test provider as usual. We have this query here. When we run it, yeah, the results show up. That makes sense. But we can start doing that thing I was talking about, which is like customizing some of the results. So let's say that I actually want this balance summary thing to only return one of them, and I want the currency to be USD. So we'll pick option 2 here. I really hope this works because it totally worked every other time that I tried it. Okay. Oh, right. So what I need to do actually is also pass those custom resolvers in. So. Boom. Great. So exactly what I expected happened, which is that I got one item in my array and the currency said USD. So I can type in like ReactSF. And one thing we'll see is actually this component doesn't want to handle any currency code that's not 3 letters. So if we wanted to test that error state, I would say it's not very pretty, but hopefully our server just doesn't return that. So, if I wanted to change this to RSF, boom, now it's very easy to test basically any version of this component with any number of these items, see what it looks like, prototype it, let's get 4 of them, boom. So now any designer using our component system can come in, use those global GraphQL mocks and even specific GraphQL mocks and build out an entire prototype UI right here. I find it very exciting. All right, so let's move on. The next tool that I want to talk about that I'm really excited about is some of the stuff we built out around schema validation. So, you may have heard about some of this Apollo tooling. We're not currently using that because we have pretty strict requirements for what types of tools we use at Stripe. But we built out some of our own things that have a similar type of functionality. So one of the things that I think is really important about collaborating on an API or like any type of code base is you shouldn't have to worry about what else is going on in different parts of that code base when you're just trying to make your own very specific change. And so our goal with all this tooling that we built out is that anything that might like screw up something else in the system, we can like warn you about automatically. So if your builds pass and your particular part of the code looks good, you should be good. So here's what we've done. we have made sure to generate a schema.graphql file from our schema, which is written in Ruby, and make sure to always check it into our repository. We have a test that makes sure you checked it in correctly. And so you can go to this file that encapsulates your whole schema and actually track, like, for every single field who added it and when it was last modified. So that's kind of part one. Part two is we generate static types for our front end with Flow using Apollo CodeGen. We'll get into that a little bit later. And three is in our CI process, we run a backwards compatibility checker, because it turns out that it's not enough to just make sure the back end and front end work together right now. It's also important that the back end works with old front ends as well. I'll get into that in a bit. So the schema.graphql thing is very simple, but I would say very important, because because I worked on this GraphQL implementation at Stripe, I now get CC'd on like a whole ton of random PRs that are related to GraphQL, because people are like, I'm not yet sure if I'm doing this right. This is still a little bit new. And 99% of the time, I just come in and I just open the schema.graphql file and I just look at that, because I'm like, your code probably works, but like I want to check if you're like messing up the schema in some way, because schema changes, while they're revertible in some sense, it's much harder to like remove something that you've added because maybe parts of the front end will use it or whatever. So I really like being able to see this diff of the schema every time somebody makes a pull request. Secondarily, we generate flow types, which have the function of making sure that our front end or back end are compatible, but also the results that we would get from our back end, from our API, are compatible with the front end code that we wrote inside our React. And one really specific thing here, this is only going to really be relevant to the like flow type generating Apollo client users in the room, that we worked on, is it turns out when it generates these static types, it generates a type for your query result and also a type for your query variables, because one is kind of like the input to the query, it's like the arguments, and the other one is like the output they use in your component. And so we've just done this small little thing that I think is kind of cool, where we've created a new component called Query Wrapper that actually imports and attaches all those types for you. So instead of having to generate those types and then separately importing the result types and importing the variable types, you just write your query here, and you just use a little parameter on your type up at the top where it says example query in the top right. And then these types are plumbed through all of your components automatically, both for the variables and whatever. And we found it valuable to have this like thin type safe wrapper around the query component, because that kind of lets us like add a couple of Stripe specific properties to it. But we're also trying to stick as closely as possible to the native Apollo client API, because we want people to be able to use the regular docs there. So essentially, you have this component. You can, in your editor, say like, oh, you tried to use this field, it doesn't exist. Pretty cool stuff. Definitely one of those key benefits of GraphQL we should be looking for. And then last but not least, in our CI builds, we have this backwards compatibility checker that exists because when we didn't have it, what would happen is we would always deploy a new version of the schema, and then people who still had their browser tab open would like navigate to a page that uses an old query, and then they would get an error. And we actually found out that some people would have their dashboard open for like literally months. And so we were like, okay, how do we like ever remove anything? So we actually added a thing there to make it refresh every 4 days. We thought that was like a fair compromise, like, and it only refreshes if you navigate. It doesn't like force you. So like, hopefully it's fine, and hopefully we feel like if we remove the query from the front end, we can then remove the backend component of that a week later and feel pretty good that we're not going to break anything. And I guess you can get this vibe where like at Stripe, we care a whole bunch about even like a relatively small number of users experiencing an error, because it's critical to us that people like trust the work that we're doing and it like accurately represents your financial data. I take that very seriously. And then, in terms of still being able to make breaking changes, we actually started using the deprecated directive functionality in GraphQL. So GraphQL has a way to mark fields as deprecated, which means you like probably shouldn't use them anymore. And so the way that you do make a breaking change and get past that CI check is you first mark your field as deprecated, then you merge that, and then you make a second PR to delete it a week later. That's not like one thing we came up with is, or one issue is that doesn't work super well for types that are not actually used. Sometimes people will like prototype a part of the schema. It's not actually used anywhere in the front end for sure. And then they just want to change it. It still has to make 2 PRs, but it's fine for now. It's better than not having that check. All right. And last but not least, of the tools that I wanted to cover today is monitoring. So like any responsible company, we want to really make sure we know when stuff goes poorly. And we have a couple of specific concepts at Stripe that make it really easy for people to find out, if their stuff is working well or not. And we wanted to tie GraphQL really nicely into those systems. So one particular thing that makes GraphQL different from the types of endpoints we were working with before is basically that there's only one URL. Everything goes to /GraphQL versus before our monitoring was like split up by endpoints and all that kind of good stuff you might expect. And also some of the important metadata about the request, like the query name or the fields in the query, are hidden inside the body of that post request. And so it's not super easy to get at them with most of today's kind of like tooling. Thankfully, we have a really easy way at Stripe to add specific metadata to requests and responses for logging and like analytics and all that kind of stuff. So we're able to extract the operation name from the query after it's parsed and make sure that that ends up in the logs. And so this is Splunk, I believe. I always get mixed up with Signal Effects because they both start with S. I think this is Splunk, and basically you can see here that we can put in a filter where we filter by GraphQL operation. You can see stuff like timing or errors or logs just for the particular query you're trying to look at. So I would say that if you're trying to implement GraphQL at your company, this is something that's like really important to have because otherwise you'll just have one giant chart for that. One other thing that I think is really cool, specifically about Stripe that I learned about when I joined, is that it has this concept of ownership of stuff. So, there's owners of different UI components, different pages in the dashboard, different endpoints in the API. And the point of that is that there's these centralized platform teams, like the one I worked on for the dashboard, that like own the general idea of like dashboard pages. But, we can't be on the hook for like every single page that might break. And so this system helps us route errors and information to the teams that need to know about it. And so we've built that into GraphQL as well. So when you write a GraphQL query, this query wrapper thing that I was talking about earlier enforces that you put down a team that basically is going to get paged when this query breaks. And so that's thread through all the way to the server using an HTTP header. It's kind of like very transparently works with like the whole Apollo client setup, which was really quite nice to set up. And now in addition to filtering by the operation name of that query, you can filter down just the queries that you own as a team, and you can set up all kinds of alerts and pages just for that query, which I think is really great and especially useful at a bigger company. Okay, so that's kind of like the three main tools. Like I promised, I didn't cover any of the tools that I had already heard of, like things like Graphical and Apollo Server and all this other great stuff. So I'm glad that was kind of already covered previously. Now, just to cap off the end of the talk, I want to talk about some of the main benefits we've seen from adopting GraphQL, and also specifically the ones that I found surprising and interesting and new to me at Stripe as somebody who'd been working on GraphQL for a long time. So just to recap the commonly quoted benefits, maybe no overfetching. You don't have to fetch data that you're not going to use. GraphQL self-documenting and has a strongly typed schema. There's really great developer tools and libraries around it because there's this huge community. But here are a couple of things that really stood out to me. First is that there's really great community tools and docs that save us from having to implement stuff ourselves. This is something we kind of heard about, but the magnitude of not having to maintain stuff internally only really hit me as hard when I went to an environment where there were so many things that we had to maintain internally. We like really felt the cost of that. And so being able to say the way that we're going to do data loading is something that a lot of people in the community are using, companies like Airbnb, for example, or whoever else is using like Apollo open source tools. We are now kind of in the same boat as them, making sure that we are not diverging too far from the beaten path that everyone else is using. Then we also found that it was much easier to add and remove fields from the schema than it was before with REST API. And also this thing about different code changes being much more localized to the feature that somebody's working on instead of spread out throughout the code base. So kind of like with the community tools and docs, we're using Apollo client for the data fetching on the front end. We're using Apollo CodeGen for flow type generation, GraphQL tools for mocking, GraphQL Ruby for the API that I should probably have listed on this slide. We're really proud of the other internal tools that were built, including the tools I've mentioned today. But we want to be really careful about which tools we choose to maintain ourselves versus which things we can take off the shelf. And I think one aspect of GraphQL that really enables this is because it's so well specified, these tools can be shared across organizations. Because it's really hard to make reusable tools like this for REST APIs. as some of you may have known. And the thing that I really didn't appreciate is the documentation aspect of this. For some of our internal tools, they're really great, but you can't Google the name of the tool. In fact, sometimes the tool has a really cool name, and then you go and Google it, and you're like, oh, it turns out this is like only an internal thing. Like the docs that I have internally are like the only thing I'm gonna get. Versus for GraphQL and all this Apollo stuff, being able to just Google it and have like 1,000 other people who have like run into this question or this problem has been like some of the most valuable stuff for us as a platform team that has to maintain a bunch of internal documentation and help people out to learn how to use it. Also, I found that GraphQL made it much easier for us to iterate on our API in a way that I hadn't really thought of before. It's very important to us that we can kind of like reduce the overall complexity of our code base. And one way to do that is to avoid doing like crazy data manipulation on the front end. And that you can only really do that if your API really matches the needs of your front end closely, kind of like that back end for front end pattern that we were hearing about. And because GraphQL has this like really low cost of having unused fields, that means it's okay to add a field that might not stick around. And one thing in particular that I wanted to bring up is this kind of like field/endpoint trade-off that we ran into. So let's say you're like really good with your application, you just want to add one more tidbit of data, and like you have a REST API, and the question is like, where do you put it? Do you put it in a new endpoint? Doesn't make sense if it's just one field. Do you put it on an existing endpoint, which isn't the best option because everyone who uses that endpoint is now going to get that field whether they want it or not? Or do you implement that field on the front end, and now you might have like duplicated logic throughout different parts of your front end, like maybe in the back end as well. So we found that GraphQL eliminated that trade-off for us and made it much easier to like keep all of that business logic and like source of truth in the schema. And front-end developers have been like much more willing, I think, to like just add more fields as they need them rather than working around it in JavaScript. And then, as I mentioned before, this idea of localized changes. So every query you write can be a new query. You don't have to worry about breaking someone else's. So in conclusion, I think GraphQL is really special because it has this wide-ranging effect across like all different parts of your stack. I'm really excited about some of the new tools that we found and different capabilities we uncovered that I hadn't really thought about before joining Stripe. And most of all, I'm excited about these like unforeseen benefits that we got to product development velocity since implementing it. So, obligatory mention, we're definitely hiring at Stripe and definitely for front-end developers and people using these systems in React and GraphQL. And feel free to either apply online or reach out to me. And also, happy to answer any questions you have, either whether that's about this talk or anything else about GraphQL.
Thank you so much.